Hi, I'm starting the discussion of topic solid state. As we know, there are the different ways to classify the matter. On the basis of physical state, matter can be classified as either solid, liquid, or gaseous one. These are the common physical states of the matter. Beside this, existence of the plasma and Bose-Einstein condensate that is also stated. Okay, most of the matter which we use in our day-to-day life, it is solid in nature. Objects, say for example clothes, here the board, marker, cell phone, and whatever the table and so on, whatever the things are there around you, around me, so most of these things are the solid in nature. So the state of matter to which we are very commonly deal with, that's the solid. And uh, the first of all, what are the physical properties of the solid? Okay, I know most of you are aware about it, but let's start with the basics. So name of the topic is solid state, and the first point here that is to be discussed is what are the physical properties of solids. Okay, first one, solids, they shows the least diffusibility. How we can define the diffusibility? ability of substance Ability of substances to intermix on its own, that is nothing but the diffusibility. The gases, they get diffused, that's why the fragrance of perfume, fragrance of the different flowers, okay, freshly prepared food having a characteristic odor. So the gaseous state, the gases are highly diffusible, but is it going to happen along with the solids? No. Okay, say for example, that this marker, if I am keeping here over the board, okay, and after few days, will that marker and will that marker and that board, are they going to mix together chemically? No. Okay, so in case of the solids, diffusibility is the least one. Okay, now next property is, I am not saying they are non-diffusible. No, it is also not said. Say for example, if I didn't clean this board, what will happen? After some days, it will become difficult to clean this board. Why? Because this marker ink and that board, so little diffusion occurs. Little strong physical forces start to occur. So that's why, yeah, the word used is solid shows the least diffusibility. Generally, the solid state of matter having the high density. So you may take the example of the metals, alloys, or the different objects which we use. As compared to the liquids and as compared to the gases, the solid state of matter shows the high density. Okay, of course, there is an exception of the ice. Even though ice is a solid form of the H2O, but its density is less than that of the water. The reason is different. Ice is hexagonal, the internal structure of the ice is of the hexagonal type, and the water, the structure of the liquid water is tetrahedral. Okay, in this topic, if feasible, we'll discuss that also. But in most of the cases, the solid state of matter shows the high density. Next one, about the compressibility. The solids are generally, the solids are incompressible. Okay, means what? We can't apply the force over the solid, and we can't reduce their shapes. It's a general terminology. Okay, and it is mostly applicable for the ideal solids. We call them as a crystalline solids. Okay, so the solid which is having the certain physical dimensions, length, width, mass, okay, and all those things. Suppose 1 kilogram of the iron in ideal condition if we took, so by the simple physical forces, it can't be compressed. Okay, generally student give the example, sir, that thermocol can be compressed. Okay, sponge can be compressed. Okay, of course, here the answer is thermocol, sponge, these are the amorphous solids, these are not true solids. Okay, so for the ideal solids, they are non-compressible, okay, or incompressible in nature. Okay, I am unable to recall it's incompressible, perhaps it's incompressible. Okay, please check. Now next is which one? Next property of the solids is, that is solid state of matter. The solids can't occupy the complete space. Okay, they can't fill container completely. Means what? I'll write here, can't fill container completely. Say for example, here we have one jar and we have kept here sugar. These are the crystals of sugar. Half kg, 1 kg sugar is get kept. So students, all you know, in between the different sugar crystals there is an empty space. So what it indicates? That the space remains empty. Okay, the complete container is not get filled. Even suppose if I fill the that sugar crystals up to the here lid, okay, so then also we know that in between the different crystals of the sugar there is an empty space, and it is applicable for the other solids too. Okay, next one is about the interparticle force. See, in all types of matter there are the two types of the forces. One we call interparticle force of attraction, another one is the intraparticle force of attraction. Okay, say for example, I am taking one here, solid. In case of solid, these are the particles of solid. You may consider these are the particles of the iron or copper or sodium chloride or anything else. Okay, say let's consider these are the particles of gold. Okay, so in between one gold atom, another gold atom, there is a certain force of attraction. That's the actually that is the metallic bond in that case. But for understanding, try to keep in mind it's a interparticle force of attraction between the constituents of the solids. So the solids are very compactly arranged. Okay, these constituents are very closely placed. Why? Because the interparticle force of attraction is very high. We are talking about the solids. And in connection with this, what about the interparticle distance? Of course, these two things are inversely related. As the force of attraction is more, interparticle distance, of course, it is going to be a less one. Okay, so this is one of the characteristic feature of the solid. Then generally about the solids, they have the fixed shape and fixed volume. Okay, some student may think and may give some other examples. Okay, they do not have a fixed shape, fixed volume, say sponge, thermocol, wood, plastic, rubber, thermocol, like that examples can be given. But we are talking about the ideal solids, true solids, crystalline solids. Okay, and for them they have the fixed shape and fixed volume. Okay, students, in connection with this we can state the properties of the liquids as well as gases also. Okay, now next part is about difference between the crystalline and amorphous solid. Okay, we'll try to see this today. It's enough. Okay, bye.